Okay, Module 4, Part 3. We are still in the development strategies for machine learning and how these development strategies are used in the within bigger system. One of the things that we have to do during the development and deployment is the monitoring of the model stallness. So this is basically means that when the model performance degrade and when the model performance is coming down, so to say, this is happened due to several issues. For example, when the data is changing or the environment is changing, when the environment and the data is changing both together also. So we can say this thing, we can name this, and in the literature, the name is data drift or model drift. Drift, which means the change. And this will occur due to several factors, as I said. We will come back to this later, but this will give inaccurate prediction. So the model stallness is exactly this, when the model performance decreases over time. So how to do this monitoring, how to identify this drift or how to detect this change. There are several things to do. For example, monitoring model performance continuously. This model performance, we continuously monitoring it, and when the model performance coming down, it means there is a performance change, and we have to do something for it for this. Or continuously monitor the change in the data, how much the data is changing, and then how much the environment is also changing. We have to keep an eye on this shift, this change. How to, if we identify some drift, how to deal with this? The first thing we can do is that, for example, the first thing to think about actually is the retraining the model with the new data. If the data is changing, it means there is a new data coming. So if the new data is coming, it means that we have to retrain the model again to create a new model, to archive the old model, and to bring the new model in production. However, for example, if the weather data is changing after 3 years, and we found that the data that we used before 3 years is not useless, is useless now. So we have to retrain the model with the recent data. However, retraining um, is not a good option sometimes, because retraining means a lot of money. Retraining means a lot of computation. If you do this retraining on cloud, it means that you have to pay a lot of money to retrain the model. Sometimes the retraining is not useful, but when you have the drift, even if you do the retraining, you have to update the data pipeline for environment change. When the environment is changing, so it's better to update the data pipeline. Yeah. So another thing we have to do during this deployment and testing of the pipeline and development is the data validation and schema test. The data validation means that, for example, if the data there are some errors in the data, identifying missing values, for example, or abnormal data like outliers. So if there's outlier, there are tests for this. You can see this logo. This logo is for a tool called Great Expectation. This Great Expectations is a very good and great tool for testing the data, for data validation, actually. Another thing is to check or test the schema validation. So you have a data format, but you want to make sure that, for example, for a 1 million data points, the format is consistent. It has the same schema, verifying that the field like time to value is an integer measure, for example. So this is, if you have it for 100 points, it's okay, but if you have it for 1 million point, it's very difficult to uh, to 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 know that the data has the same schema. So you have to test it. And if you do this continuously during the machine learning pipeline or ML ops pipeline, and you do it in real life, that will be very challenging. Also, we have other tests, like, as I said, expectation test, the format and validation, as we said in the Great Expectation. Um, for example, the average time spent on a website, that is the expectation. So if we have the average time spent over a website is around 4 minutes with a standard deviation of 1 minute, for example. So is it is the data arriving is expected or not? Holdout testing is also something, for example, evaluating the model reliability with a new data set, with a separated data set, how well the model perform or unseen data set. So detect issues like overfitting or underfitting. This is also something that we can do with holdout testing. Feature importance testing also, which feature is most influential on the machine learning model. How to do this is also very important to do. Data and model drift, also something very important to do during the development and deployment. Monitoring for drift is very, very important. For example, feature drift involve change in the distribution of the model's input data. So if the model input data is changing, how label drift, for example, change in the distribution of the label. For example, a shift in user queries from return requests to inquiries about um, return status. Concept drift, the shift in the relationship between the features and responses. Prediction drift, when there is a shift in the distribution of the model's prediction. So all these are drift you can test somehow. So for example, as I said, evidently is very important tool nowadays to do all these tests. And it's open source also. So how to do this drift? The simplest, very, very simplest thing to do to know the drift by programming, of course, not by API, because, for example, evidently you can just call an API and check for drift and do all kind of drift testing. So, for example, here you go for a normal fitting of the model in machine learning, and you get the accuracy here. Train classifier, you train it, you calculate the accuracy for a test data. Now, if we want to test for the drift, for example, you change the distribution of the data, and you change the distribution of the data a little bit, and then you get the accuracy again for the new data that you change the distribution. Now, you have a model with the original data, and now you have a model with the shifted data, and you have this drift detection threshold based on the accuracy, and you say that the threshold is accuracy multiplied by 0.9. So this is the drop of the accuracy. And if the accuracy drop is the if the accuracy drift is less than drift threshold, then you say the drift is detected. If not, there is not drift. Of course, there is a simple short drift, but is not due to this threshold because the accuracy is changing a little bit, not more. So if you change the distribution more, then it means that it's far from the threshold, and then that's the drift. However, this is not the case for the new tools. So this code is just a simple code to know how it works. However, the new tools like Evidently and other tools and other algorithms, you just give the base data and the new data, and then it will give you the drift, how much drift you have, and you can even visualize it. So when you have the deployment, when you have the model in the deployment, you have to have the entry point, and the entry point for this model is the API, the application programmable programming interface. So this is the interface that you give an input to input data and you get the prediction back. There are many examples of interface and APIs. For example, you have to ready-made APIs for you. You can use the sentiment analysis API, which is by Amazon, for example. You send the text data and receive sentiment analysis result in response. You have Twitter API to get the data about tweets. You have New York Times API, which is you send some request to the New York Times API and you get like example of like articles or content published by New York Times. Now, what is the architecture of API? Simply, there are many architectures for API. For example, we have REST, we have RPC, we have SOAP, and so on. So, for example, the API that calculate the estimated time for arrival. This is very simple API, for example, and you send the distance and everything, and you get the estimated output, the estimated time. However, if you look at this picture, it's like some input data, you send some input data, you get some feedback as the output. However, this is not exactly what it should be. So you have steps for this. For example, we have to verify and input validation for the API. For example, if the API is expecting the velocity and distance to be numbers, integers, and if you enter, like for example, some letters, like in this case, there should be, before sending this input data to the API, there should be some verification. So for example, you have to give some informative error message, for example, invalid request, or V should be more than greater than 0, and so on. So that's the input validation. You get the request, but you validate the input before sending it to the model to response. Another thing is that the output validation also, if you send it to the model and there is some output error, it means that you have to give an informative message as an output, not just an error message. Say that, sorry, an error occurred, we are working on it, for example, or something like that for the server. So things like that is very important for the input. Also, not everybody should send an input for your API if you create an API for your application. So there should be input validation and API throttling. The input validation, for example, before processing any request, the input Validation should ensure that the income data meets an expected format and criteria. So that's the most important thing for the authentication, like for example, some secret key or password and so on. And also this throttling is that you have to specify in your API that how many requests you are getting. For example, if somebody tried to make your system down by sending thousands of requests, and your model cannot handle thousands of requests per second, it means that you have to limit and to test this. That is going also through the authentication of the input and validation of the input. Finally, when you have the model, you have to maintain the model. There are two approaches for maintaining the model. As we said before, we have model-centric and we have data-centric. The model-centric is the problem because you have to change a lot of things. However, new research says that the data-centric is very promising due to several advantages. For example, when you change the data, when you try to clean the data, um, you will get very, very high performance improvement. But also, you should focus on quality over quantity. So having more data doesn't mean necessarily that it is good, but having high quality data is more important, and that will lead to maintain and to improve the model and to improve the prediction or classification or whatever the model is doing. So also in your data, you should focus on relevant features and labels. We want to have features that actually improve and relate to this model and carry out relevant information. And also the labeling, we want to make sure that the labeling are accurate and all the data has labeling, and more labeled data is good always.